Question 24, a pretty busy reading or looking probability question. So in a nutshell, there are 3 black tokens and 6 white tokens inside box A, B, and C. The order of things that we're going to be doing here is we select one at random from box A and put it into box B. We then select one at random from box B and put it into C. And then we select one of the beads at random from box C and put it into A. And after all is said and done, the question basically wants us to find the probability where there are still 3 black beads and 6 white beads in each of the boxes. Now, given the fact that we're going from A to B, B to C, and C back to A, the only way that you can have the same number of black and white beads in each box at the end as you have at the start is if you are removing a black bead followed by a black bead followed by a black bead, where basically one of them is moved each time, and then in the end there's still 3 black beads in each one, or you have a white bead moving each time from each one. So our probability is basically we have 2 options here where we are drawing a white from box A, then a white from box B, then a white from box C, or we draw a black from box A, then a black from box B, then a black from box C. So we split this up into 2 sections here. We're going to go A, then A, then A, and B, then B, then B. Chances of getting an A from the first box here is 6 out of 9, so that's our probability for the first one. Now we are then going to be looking for what the probability is of selecting it from B. So we are looking for a multiple because we have the probability of the white that we drew from it followed by or and a probability of selecting a white from the next one. Because we added a white to that second one, it is out of 10 now, and the top is out of 7. So this white, for example, if we move it here, there are now 7 whites and 3 blacks inside that, so there's a 7 out of 10 chance. When we move it into this box here, we are then going to also have a 7 out of 10 chance of getting the white that's in there, because again, one of these whites is now moved in there, 7 whites, 3 blacks. And if we multiply all these together, we're basically saying that all 3 of these situations happen, where we get a white from here, and then a white from here, and then a white from there. Conversely, if we do this with the blacks, we'll have 3 out of 9 to start with, and instead of it being 7 out of 10, because we added an extra black for each of these, we will have 4 out of 10, because, for example, if this black here moved in, we now have 4 blacks, and the same would go when we go from B to C. So we find the products of each of these. You can simplify your fractions. You can type it in the calculator if you want in one go. We're going to end up with 49 150ths for this one. We're going to end up with 4 75ths for that one. We have either of these being an acceptable outcome for they're ending up with the same number of whites and black beads in either one. So what we do is we add these 2 probabilities, because either are acceptable, therefore our chances of it happening are increased because we have more options. So if we add together these 2 fractions, what you will end up with is fully simplified 19 over 50ths. Now, of course, when you're dealing with these probability questions, and given the fact that you have a calculator, you don't need to really worry about doing this without a calculator, or when you're adding fractions having to show a common denominator or anything like that. You can just go ahead and actually use the calculator to do the calculations, and you'll end up with 19 over 50. If you did do it without a calculator, or just you didn't simplify it, maybe your calculator doesn't simplify fractions, this here would have also been an acceptable probability. Same thing either way, and we're done.